Hi, our topic for today is about integrals leading to inverse trigonometric functions. So at the end of this lesson, you must be able to evaluate integrals leading to inverse trigonometric functions. Okay, so to start, let me discuss the basic formulas for integrals leading to inverse trigonometric functions. So the first formula is the integral of du over the square root of a squared minus u squared. So this is equal to arc sine of u over a plus the constant c, where a is greater than 0 or positive and the absolute value of u is less than a. So take note of the denominator now when using this formula. This contains radical sign and the radicand is of the form a squared minus u squared. The second formula is the integral of du over a squared plus u squared. And this is equal to 1 over a times arctangent of u over a plus the constant c. Again, take note of the denominator. This does not contain any radical sign and the operation is addition and the form is a squared plus u squared. The third formula is the integral of du over u times the square root of u squared minus a squared. And this is equal to 1 over a times arcsecond of the absolute value of u over a plus the constant c, where a is greater than 0 and this is less than the absolute value of u. So take note again that the denominator is contains radical sign is and of the form u squared minus a squared. And there is a factor of u outside of the radical sign. So to apply the formula, let's have the following examples. So number 1, suppose we are asked to evaluate the integral of x dx over the square root of 25 minus 9x to the fourth power. So as you can see, because the denominator contains radical sign, either you use formula 1 or formula number 3. But because the radicand has contains this order of terms, constant first followed by the function of x, so we can make use of formula number 1. And from here, now we can use the following representation. A squared is 25, which is the constant, and u squared as 9x to the fourth power. And then taking the square root of both sides, so we got a equals 5, and for u squared equals 9x to the fourth, u is 3x squared. And then by taking the differentials of both sides, so du equals 6x dx. And if you look at the integrand, x dx is part of this differential, but 6 is missing. So by using substitution, we have to remove this constant 6 from this side by dividing both sides by 6. So we get x dx equals du over 6. Or you can rewrite this by substitution as the integral of, recall that x dx is du over 6. All over the square root of 25 is a squared, 9x to the fourth is u squared. And because 1 over 6 is constant, so you can factor this out. So we have 1 over 6 times the integral of du over the square root of a squared minus u squared. Okay, but recall that the integral of du over a square root of a squared minus u squared using this formula is equal to arc sine. So you have 1 over 6 times arc sine of u over a plus the constant c, where u is 3x squared. So we have this all over a, where a is 5. So we have 3x squared all over 5. So therefore, the final answer is 1 over 6 arc sine of 3x squared all over 5 plus the constant c. So this is the final answer. Okay, so let's take another example. So for number 2, we are asked to evaluate the integral of dx over x squared plus 10x plus 26. As you can see, because this does not contain any radical sign, so you have to use formula number 2, which states that the integral of du over a squared plus u squared equals 1 over a times arctangent of u over a plus the constant c. So to transform the denominator in the form of a squared plus u squared, we have to transform this to perfect square trinomial plus a constant. And to do that, you get the half of the x coefficient. So 1 half of 10, so that's 5. And then you take the square of 5, so you get 25. But since the constant term is more than 25, so you divide this into two parts. So the first part is 25 and the second part is 1. Then you combine 25 with the first two terms to form a perfect square trinomial. And this can be factored into x plus 5 to the second power by taking the square root of the first term, so x, square root of the last term, so that's 5, and then copy the sign of the middle term, so you have plus. And then raise this to the second power plus the constant 1. And as you can see, the transformed denominator is of the form u squared plus a squared, where a squared is 1 and u squared is x plus 5 to the second power. Then taking the differentials, taking the square root of both sides, so a equals 1 and u equals x plus 5. And then taking the differentials of this equation, so you have du equals dx. Then by substitution, you can now rewrite this as dx is du all over x plus 5 to the second power. This is your u squared. And then 1 is a squared. And then recall from the formula that this is equal to 1 over a times arctangent of u over a plus the constant c, where a is 1. So 1 over 1 is 1 times arctangent of u, where u is x plus 5, over a, where a is 1, plus the constant c is the same as arctangent of x plus 5 plus the constant c. So this is the final answer. So in summary, use the formula of the integrals that leads to inverse trigonometric functions to the integrals that match up the correct format using substitution.